Imagine you set out on a road trip, you packed your car, made a playlist, and set out to drive 200 kilometers. But you don't actually know where you're headed. You remember to top off the gas tank before you leave and pack snacks, but you arrive at a destination and it's not at all what you imagined it would be. Now, running an experiment or any research for that matter, without a hypothesis is like starting out a road trip just for the sake of driving, without thinking about where you're headed and why. You will inevitably end up somewhere, but there's a chance you might not have gained anything from that experience. Creating a hypothesis is an essential step of data collection or running experiments. Although you can set up and execute an experiment or research without one, I strongly advise against it. I even argue that a strong hypothesis is as important as understanding the statistical significance of your results. A hypothesis is a precise, testable statement of what the researcher or researchers predict will be the outcome of the study. This usually involves proposing a possible relationship between two variables: the independent variable, or what the researcher changes, and the dependent variable, what the researcher measures. Now, in the context of correlational research, it is possible that you don't have an independent variable, but you have, or a dependent variable, but you have two variables in which the relationship you want to discover. So in research, there is a convention that the hypothesis is written in two forms: the null hypothesis and the alternative hypothesis, called the experimental hypothesis when the method of investigation is an experiment. Now, according to the APA Dictionary of Psychology, a null hypothesis is a premise that describes what a researcher in a scientific study hopes to demonstrate if certain conditions are met, such as random selection of participants, random assignment to experimental group or control group, again if the research is experimental in nature, and manipulation of an independent variable. In its purest form, a hypothesis is a suggested solution for an unexplained occurrence that does not fit into current accepted scientific theory. The basic idea of a hypothesis is that there is no predetermined outcome. For a hypothesis to be termed a scientific hypothesis, it has to be something that can be supported or refuted through carefully crafted research or observation. This is called falsifiability and testability, an idea that was advanced in the mid 20th century by a British philosopher named Karl Popper. Now, there are basically two types of hypothesis, namely the null hypothesis and alternative hypothesis. The purpose and importance of the null hypothesis and alternative hypothesis are that they provide an approximate description of the phenomena. Moreover, they provide the researcher or an investigator not only with a relational statement that is directly tested in a study, but also a framework for reporting the inferences of the study. They serve as a working instrument of the theory that allows the establishment of whether or not the test is supported, which is separated from the investigator's own values and decisions. Essentially, null and alternative hypotheses provide direction to the research. The null hypothesis is generally denoted as HO or H0. It states the exact opposite of what an investigator or experimenter or researcher predicts or expects. It basically defines the statements which states that there is no exact or actual relationship between the variables. It also states that results are due to chance and are not significant in terms of supporting the idea being investigated. The alternative hypothesis is generally denoted as H1. It makes a statement that suggests or advises a potential result or an outcome that an investigator or the researcher may expect. It states that the results are not due to chance and that they are significant in terms of supporting the theory being investigated. It has been categorized into two categories: the directional alternative hypothesis and non-directional alternative hypothesis. So, a two-tailed non-directional hypothesis predicts that the independent variable will have an effect on the dependent variable, but the direction of the effect is not specified. On the other hand, or rather consider this question: do students who attend more lectures get better exam results? For example, there will be a significant difference in the exam scores of students who attend more lectures and those who attend few lectures. A one-tailed directional hypothesis predicts the nature of the effect of the independent variable on the dependent variable. For example, students who attend most lectures will have significantly better exam scores than those who attend fewer lectures. So, upon analysis of the result, a hypothesis can be accepted, rejected, or modified, but it can never be proven to be correct 100% of the time. Again, let me repeat that. It can be accepted, rejected, or modified, but again, it can never be proven to be correct 100% of the time. For example, evolution has been tested many times, so it's generally accepted to be true. But there could be an instance which has not been encountered where it's not true. For example, a scientist can form a hypothesis that insufficient justification can lead to cognitive dissonance. During research, the scientist then finds that insufficient justification led to cognitive dissonance. Though his findings confirms his hypothesis, there may be an instance where insufficient justification does not support or produce cognitive dissonance in other cultures. Thus, hypothesis is true, but it may not be true 100% of the time. So, we must avoid any reference to results proving a theory, as this implies 100% certainty. And there is always a chance that evidence may exist which could refute a theory. So, what are the checklists? What's the checklist, or what are the things that you need to consider in writing a hypothesis? First, does your hypothesis focus on something that you can actually test? The second is, does your hypothesis include both an independent or dependent variable, or a predictor and an outcome variable? The next is, this is just for experimental research. Can you manipulate the dependent variable? So, in non-experimental research, this is not expected, or this is not required. The next is, or lastly, can your hypothesis be tested without violating ethical standards? We have seen a number of researches in the past that may have scientific value but has violated ethical standards. So we need to make our research both scientifically important and ethical at the same time. So, to write the alternative hypothesis and null hypothesis for an investigation, you need to identify the key variables in the study. The independent variable is manipulated by the researcher, and the dependent variable is the outcome which is measured. This is just for experimental research. But for correlational research or any other types of research, you don't need to manipulate the independent variable. You just need two variables, and you just have to test the relationship between these two variables. The next is you have to operationalize the variables being investigated. Operational variables or operationalizing definitions refer to how you will define and measure a specific variable as it is used in your study. The third is decide on a direction for your prediction. If there is evidence in the literature to support a specific effect on the independent variable on the dependent variable, write a directional one-tailed hypothesis. If there are limited or ambiguous findings in the literature regarding the effect of the independent variable on the dependent variable, write a non-directional two-tailed hypothesis. So number 4 is that a good hypothesis is short. That is, it should be concise and comprises clear and simple language. The fifth is that you have to write both null and alternative hypothesis. So, to identify your variables, you can write a simple prediction in if-then form. The first part of the sentence states that the independent variable, and the second part states the dependent variable, as you see here in the example. If a first year student starts attending more lectures, then the exam scores will improve. So in academic research, however, hypotheses are more commonly phrased in terms of relationship or effects, where you directly state the predicted relationship between your variables. For example, for your null hypothesis, the number of lectures attended by first-year students has no effect on their final exam scores. You can even, if you're not conducting an experimental research, you may express this in this manner. There is no significant relationship between the number of lectures attended by first-year students and their final exam scores. Now, the number of lectures attended by first-year student is assumed to have a positive effect on their exam scores. So, if you're comparing two groups, the hypothesis can state that what difference you expect to find between them. For example, for your null hypothesis, you might say that there is no significant difference in the exam scores of students who attended 3 or more lectures and those who attended 2 or less lectures. And your alternative hypothesis should say that there is a significant difference in the exam scores of students who attended 3 or more lectures and those who attended 2 or less lectures. So, a hypothesis is a statement that can be tested by scientific research. If you want to test a relationship between 2 or more things, you need to write a hypothesis before you start your experiment or data collection. In this video, we talked about the steps in writing a strong hypothesis. Again, this has been Dex Kamitan, and thank you for watching.